That's, I drop it, that's the cause, the effect is it falls. We've been doing this in class already. So, on Wednesday, we did this experiment. I want you to turn and talk to your partner and identify what is the cause, what is the effect. You got 30 seconds. Okay.
What the cause and the effect, right?
Yes, and you're turning to your partner and discussing what was the cause, what was the effect.
From
Remember?
the question?
Yeah,
Okay.
because they did this on day.
Yeah.
So.
The mass of the car.
Okay, Ms. Salcedo, can you tell me which, what is the cause, what is the effect?
We said that the cost was the weight of the car.
Okay,
The effect or the mass of the car.
Now
Yeah.
wait, it's mass.
And then the effect is, the speed of the car. Wait, is it? going down?
force.
The force.
yes, the amount of force. So, just to review, we learned that this was the independent variable, which is the cause. This is the dependent variable, which is the effect. Okay, so that's how we remember our variables, independent, dependent. All right, we're gonna watch this short video. I want you to look at the video, and when we finish the video, you're going to tell me what is the cause and effect relationship between the astronaut and how he's making a peanut butter sandwich. Can y'all hear me?
No.
Right, so the first thing we need for our sandwich is a piece of bread. Well, up here we don't have bread like you do on Earth, but we have tortillas. So we use tortillas a lot for sandwiches. So that's what I'm going to use for my peanut butter and jelly. I'm going to stick that down to some tape here so it doesn't go floating away while I'm getting everything else ready. So I'll get my peanut butter out, and even the lids on the peanut butter have a piece of Velcro on it so they don't go floating away. If I let it go, it'll kind of just float there for a little while, and then eventually the air conditioning system here will take it away somewhere else. So I don't want to lose it, so I'm going to stick it on the table. I'll scoop out some peanut butter for my sandwich. I got to stick this somewhere, otherwise it just goes floating away too. But just for now, for just a few seconds like this, I can just leave it and let it float. I'll spread the peanut butter on my sandwich, onto the tortilla, and then I get my jelly ready. It's a lot of things you got to think about and manage while you're eating up here. And you just spread the jelly on the sandwich. That as well needs to get attached to the table. So there's my peanut butter and jelly tortilla or sandwich. From up here, I'll just kind of close it up and enjoy. See if you guys can enjoy it as it's coming to you.
Okay, so again, you're going to write on, this is number 3 on your response, number 2 on your response card. What cause or effect relationship did you see the astronaut using in the video? 1 minute. Okay, Ms. Easterwood, I really liked what you wrote. Can you please share?
So I wrote, the cause is not having gravity, and the effect is all things are floating away and having to be taken down.
Correct. Remember this is Monday, sorry, I forgot. Remember our objective, the relationship between force and motion and the cause and effect relationship between force and motion. Our objectives. Okay, we're going to read about the cause and effect relationship in forces in science. So we're going to make that connection. So take out your reading selection here. Okay, so if you look here, we're going to call this question A. We're going to find question A in this part of the reading selection. Notice it says CE. So I also want you to look for a cause and effect relationship. So you're going to take your highlighter and I want you to highlight QA. When we read our selection, I'm going to give you the question in a moment. When we read look at our question, we're going to go back. We're going to read in the selection to find the answer. Then you're going to also look for cause and effect relationship. I'm going to model, and then you're going to do. Notice that I have an A and a B. That means the A is going to read and the B is going to follow along, annotate, and look for cause and effect relationship. Okay, so let's look at the question. The question is, describe how forces on an astronaut body have different effects in space than on Earth. Again, so we're looking for the forces and how they affect the astronauts in space. Okay, so I'm modeling the first part. Videos of astronauts inside an orbiting spacecraft often shows the astronauts floating off the walls. On Earth's surface, gravity pulls people and objects to the ground. But things are different in space. Okay, so the question was, how does it affect the astronauts? That's why I highlighted the astronauts are floating off, bouncing off the walls. Then I highlighted gravity pulls people and objects. And notice that I put a C, gravity pulls people, and the effect is the objects are pulled to the ground. So the gravity is the pulling force, and the effect is we're on the ground. Okay, so now it's your turn. A, you're going to read part A. B, you're going to read part B. Remember, we're highlighting. I'm going to put the question here, so if you need to go over the question again, you're going to, again, mark and see if you can find at least one cause and effect relationship. I'm going to give you 3 minutes, and I might stop it just to check in to see where you're at. Again, describe how the forces of an astronaut's body have different effects in space than on Earth. All right, 3 minutes, go. Remember, partner A needs to read to partner B. And then read, is going to read to partner A. So here, she's gonna, no, you're gonna read this paragraph, and she's gonna follow along, and she's gonna highlight and annotate. And then she's gonna read this part. Okay? Right.
I'm reading it. Okay. So the gravity forces of the astronaut is almost the same inside the spacecraft as it is on Earth's surface. Earth's gravity causes the spacecraft and the astronaut to constantly fall. But they are also moving forward. So instead of falling toward Earth, they fall around it. That's kind of interesting.
Right, an object is an object in free fall that is in a stage of microgravity. It says that almost no gravity is acting on the object. Objects and liquids in the space station are part of a system. The effects of microgravity on the system is that people and objects are near to float. So, microgravity is the cause.
So it appears to float.
You have 2 minutes.
Okay, so can you share, let's go back to our reading selection. Can you share one on this paragraph right here?
We put the cause was, Earth's gravity, and the effect was that the spacecraft and the astronauts constantly fall.
Okay, sorry, I should have been more specific. Thank you for the cause and the effect. Okay, so what about the astronauts? How are they changing and moving?
Moving forward
Yeah, they're moving forward.
and falling.
Okay.
And falling. Okay, Mr. Garza, can you tell me, on part B right here?
Yeah, on that one, it was the state of the microgravity, that was the cause, and the effect was the effect on that the people and the objects appear to.
And can we also say that, okay, so what did you highlight?
On the last one, we highlighted the effect of microgravity, that's the cause, and then on the last sentence. And on the last part, that was the effect.
Okay, turn the page. So we're gonna have a new question. Again, we're gonna repeat the same process. You're going to, partner A will read, highlight, annotate, B will listen, and then again, switch.
I see where that helped you.
Okay. Thank you, Mr. Cortez. Okay, so everyone go ahead, you should have the Love It on the Wonders, on your desk. You know, so give us a couple of Love It's and some Wonders. If you have any questions, again, you can base it off of the instructional practices from the SPOT skills form. So I'm gonna give y'all about 2 minutes. And then we'll give Ms. Cortez some feedback. Nothing great.
Granola, some fruit snacks, and there's some chocolate.
Got about a minute. Anybody still need more time, or we're good? Okay, we have about 30 seconds, but I'll go ahead and stop it. It seems like most of us are pretty much done. So, some love it and some wonders. Anyone want to share out first?
Well, the great video, because it got you intrigued, because it was an interesting topic, and it showed a live person in space, and that's something that they can, they can relate to, so because that is just like, wow.
It actually was a roller coaster that they did on Wednesday, so I changed it.
So the video, so basically.
I changed the video because it was, I don't know why, but they showed the same video, which was a roller coaster, that was for today, and I'm like, this doesn't make sense. So I changed the video.
Any other love-its? Any other, or a wonder? Mr. Johnson?
I just liked it, because it's something that's the force, and she explained it very well, but I liked it. I have no wonders about it. It was good.
You guys over here?
I really like how you have all your scalpels. I really like how you are labeling the readings. That way you know how you do a teacher and then expect them to do exactly what you did on the other ones. The peer expectations and how it will just flow.
Scalpels, yeah, definitely, sure. I wrote the same thing, annotating the use of the highlighters, you were modeling for them, and so that was great. That was a lot of scalpel. Any wonders?
I even love it. I like how you, after the writing activity, you close it by stamping with the learning objective. Now my wonder, it's actually the same polish that I said, like for exemplars. Use your own writing as an exemplar so that your students would know the expectation for your short constructive responses.
Yeah, absolutely. And then something that provides a visual of, hey, this is the final product that the student needs to produce. And
So basically, show this. This is me.
No, so for your, whatever was that first
The
one that
response
we
one.
did, for the response card,
Oh, okay.
how
okay,
would you
response card.
answer that? So
Okay.
that would be your exemplar,
Okay.
okay?
The response.
Okay.
And then, Mrs. Sweet?
Basically what everybody else said, I said I'd like how you align the reading to the cause and effect, you align the science with your reading, so you're using more than one subject. I like the purple for reading and with what to annotate, because a lot of students don't know how to do that. I like how you refer back to the learning objectives. I don't really have any wonders. It was more of
Well, I kind of have a wonder. I'm like, am I doing too much in making them
So
think of the question and then also doing cause and effect
I think
between that? That's what I wonder if it's.
when I teach, cause I know you said that you changed the video, but I noticed that with our students, the ones that I have this year, sometimes they don't know how to think outside the box. So I have to bring the example to something that they know. So, for example, today we were talking about gravity. And so I know the definition of gravity is a force that pulls you down to the center of the earth, right? And so that's all they know, that's gravity. So then one of the questions on the DOL was, if there's no air resistance, and they all got, I had already planned for the question, because I said, I know they're gonna get stuck because they don't know what air resistance is. So I show them there's a place in Houston that has where you can fly indoors and the air pushes down. So they're like, oh my God, that is so cool. And I said, okay, but what is pushing you up? So that's the resistance, that air is causing that resistance, because if not, gravity is good. And they're like, oh, okay. So that made a connection to something that they would be interested in this.
And that's a good way to scaffold for them to understand.
Yeah.
But my question wasn't, it was, am I doing too much by having them, first of all, find the question, and then also look for cause and effect?
What if you already adding the Q and A in here, you don't wanna just maybe write in the question in here? Cause I did write it in to remember what I was looking for.
Okay, yeah, so, yeah, okay, 'cause no,
Cause
they
I don't
actually,
forget.
it was actually on their student activity, but a lot of the student activity, it's a lot of stuff, and I'm like, and I try to cut it down, so I can just
Or
print it.
maybe put some googly eyes and say, look for, and then just give me like a, cause that's what I did, I said, okay, she said cause and effect, and what forces affect the astronauts in space? And that's what I
Okay,
did.
so I'll just make a copy of this.
Yeah,
I'll just make a copy of this so they know what's the question.
Yeah,
Okay.
but also I just feel like, cause there was like a question, like how, what was the question?
yeah, I've heard that
What was
already.
the question? So, how forces on an astronaut's body have different effects in space than on Earth? So we did do the cause and effect, but I
But maybe
just feel
dig
like
more into the,
yes,
the-
the effect, like, I just feel like we didn't get into really answering
Answering.
that question.
Okay.
So,
so
because
really,
that they're talking about how different effects in space than on Earth. So over here, it says like, on Earth, the gravity pulls us down, right? But in space, the astronauts are floating. So I don't think like
So maybe
we really
take more-
answered that question.
Okay.
Like we just did
Maybe
the
I'll
cause
just
and
put a-
effect.
put a slide and just to make sure that we're.
Yeah, so
Okay.
just make sure to come back to that
To that
question,
Have you ever heard
okay?
John Mayer, he has a song called Gravity. I didn't play the whole song, but there's a part where he says, gravity wants to bring me down. And the kids are like, it's what gravity does! Just, you know, a little snippet of the song.
There you go. If please give Ms. Cortez your love it and your one, please, thank you. All right, next we have up Miss Eastwood.
Find this video short to myself, the way this peanut butter, that was a big video.